This is the assignment that we've been working on for this semester. I mean this week, and we had asked to implement a couple of mongoose models and a couple of DAOs, and I believe we've implemented a couple of these. We've implemented students. We've implemented sections. So if we go here, we have students and sections. But the assignment really asks us to implement, students, answers, questions, quizzes, and whatnot. But this many-to-many relationship that we have here of enrollments between students and sections is pretty much the same implementation that we would have for answers here, right? That have students and questions, and so you just like you have in enrollments a foreign key that references students and references sections, we would have something similar. Answers would have references to the student in this question saying, hey, this is the answer that this student gave for that particular question. Okay. Also, this should give you a chance to practice many-to-many relationships, and just like we did for the enrollment. So you should be able to grab more or less what we did for the enrollments, right? And if you've just replaced enrollments for answers, you'll be able to create the this relationship between these two. Okay. Now in UML, it's drawn slightly different, right? In here we notice this is it's an association class, and this association class it's an association class because not only do we have foreign keys back to these two, right? But we also have additional fields. So this answer here, notice that it's using the wrong nomenclature, right? This answer, it's actually should have been drawn as an association class, right? Because notice that not only do we have relationships between a student and a question, but I also have additional fields here, right? So this is using the old UML 1.0 standard, right? That we just drew it with a many-to-many was implemented just with two one-to-manys. But today we're using UML 2.0. We would use the association nomenclature to render this, right? So this is also an association class, but it's drawn using an older style. All right, so we played around enough with many-to-many. Let's play around now with quizzes and questions. Okay. Notice the implementation here. This says that this is it's not an aggregation like this one, right? Instead, if it's a composition, meaning that the questions presumably can exist outside of a quiz, right? And in reality, in Blackboard, for instance, you can have a question that could be used in multiple quizzes. So Blackboard would implement it as an aggregation, right? Because the same question could exist in two different quizzes, in an exam, in a final exam, and whatnot. But in here, it's being documented as a composition, and what it means is that if I remove the quiz, I lose all the questions; they're gone, right? So let's see how we would implement that. Also, notice that it's a one-to-many, right? So meaning the quiz is going to have several instances of this. So this could be implemented a couple of ways, right? We could implement the classical way in a relational database. The only real way to implement this would be for the question to have a foreign key back to the parent quiz. That's the only way to implement it, right? And to implement the fact that this is a composition, we would have to have a cascade, right? Cascade delete, meaning that if I remove the quiz, I would remove also the children. They would be gone. Now, in non-relational database such as Mongo, right, because we can store complex objects, right, and objects within objects, and they can have a fairly more complex schema. What we can do here is that quizzes can contain as an array, right, can contain multiple questions, right? Literally, right, we can say that the data type for the questions, right, inside of a quiz is an array of questions, right? And I'm not quite sure if that's what we're suggesting here. Yes, we are. Actually, no, we're not. Notice that. Oh, okay. Yes, right. So here we have one way to implement it, right? Is that we have an array, and here we have it's going to be an array of references, right? Notice that this is an array, and what's going to be stored in each array is a foreign key to a question, right? So this actually does not implement the composition relationship, right? Because notice that if I remove, right, if I remove from the question, if I remove, I'm sorry, if I remove the quiz, I'm only removing it from the array, right? The question instance would exist in a separate questions collection. See that? All right. So let's explore a little bit how we would go about implementing this kind of relationship. All right. So let's do that using the composition, right? And here in the assignment, follow the instructions using, here what we're using here is that we're saying that we have an array of IDs, right? We're saying that a quiz is made up of an array of questions. So yeah, follow this implementation. I just want to give you an alternative implementation, right? Is there a question here? Instead of click request control, please ignore. Oh, give control presenting, give control. No, okay.